Hello everyone. We're going to go over a moles question from the A-level chemistry classified question paper, and you can find the link here if you want to carry on with the rest of the paper. So the aim of this is to give you a refresher on moles. Perhaps you're back from summer or just want to brush up on the knowledge you already have. I believe even a GCSE or IGCSE student would be able to follow along. So without further ado, let's get started. Right, so our question says, a student carries out a titration to find the concentration of some sulfuric acid. The student finds that 25 centimeter cube of 0.088 mole per decimeter cube aqueous sodium hydroxide is neutralized by 17.6 centimeter cube of dilute sulfuric acid. And we can see the equation here. So calculate the amount in moles of sodium hydroxide used. Before we do, just a refresher on what titration is and how it works. So in this example, we have a known volume and concentration of our NaOH, our sodium hydroxide. So that would be in this conical flask, and then we have a volume of dilute sulfuric acid measured at the beginning of the experiment, and then we keep dripping. There's an indicator here as well. So as soon as that color of our base changes, we know that neutralization is successful, and then we measure the volume of the acid at the end of the experiment, and our delta here is the volume, which is in this case is 17.6 centimeter cube. And then we can use all the information we have. So we know the volume and concentration of our base. We know our volume of our acid. We know this lovely equation. So we know the ratios of the moles reacting. So we can find all the rest of the information on our acid. Right. So very simple question here. Calculate the amount in moles of sodium hydroxide used. So we know we have 25 centimeter cube of the sodium hydroxide, and then we have 0.088 mole per decimeter aqueous sodium hydroxide. So all we need to do really is convert the centimeter cube. That's not a cube, that's a square. Now it's a cube. By 1,000. So we get this in decimeter cube. Let's just do everything at once. So this is now in decimeter cube, and then we multiply that by 0.088 mole per decimeter cube, and now we got, if we plug that into a calculator, we get 0.0022 moles. So that should be our answer. And we got our first mark. That's easy. Again, we just converted the units, and pretty straightforward, I think. So that's the first question, and then the second part is determine the amount in moles of our sulfuric acid used. So again, we need to refer to the equation here. So the ratio of sulfuric acid to sodium hydroxide is 1 to 2. So, oops. What's happening here? Yeah. SO4 to NaOH is 1, 2, 2. And then we know this from the previous part, so that's here 0.0. So this is our very simple cross multiplication. So multiplied by 1 divided by 2, and then the answer would be 2 zeros here. And it's yeah, same unit in moles, so 0.0011 moles of sulfuric acid. Right. Next part, calculate the concentration in mole per decimeter of sulfuric acid. So we have the moles of sulfuric acid now, and all we need to do is divide the moles by the volume that we already know from the question. So that's the amount of moles we have in mole divided by the volume, but then again we need to divide that by 1,000, so it's in decimeter cube. So just so you always remember that, divided by 1,000 to give us decimeter cube. Right. So let's do that. So that's going to be 176. And if we plug that into a calculator, we got I'll write the answer in here. So 0.625. So that's our sulfuric acid concentration in mole per decimeter cube. And then next part B. So after carrying out a titration in section A, the student left the resulting solution to crystallize. White crystals were formed with a formula of NaSO4, which is sodium sulfate, and that's a hydrated salt. So that's how the hydrous or hydrated salt formulas look like. And then we have here an unknown amount of water molecules represented as X, and a molar mass of 322.1 gram per mole. So they were nice enough to give us the molar mass. So what term is given to the .x H2O part of the formula? So in this type of questions, you would straight away say that it's the water or amount of water of crystallization. So water or number of water of crystallization. And then the mark scheme says that hydrated or hydrous will be ignored as an answer to this. So that's the answer for now. And then using the molar mass of crystals, calculate the value of X. So this is a repeated question. Again, it's very simple. So let's look at our results. We have Na2SO4 and then dot, and then we have, come on, H2O, right. And we have the total molar mass which equals to 322.1 grams per mole. Right. So what we do in this type of questions is we look at the molar mass for this bit first, and then we always know that the molecular weight or molar mass of water would be 18 grams per mole. And for this, so sodium is 23, so 23, and that information is in the periodic table. So 23 times 2 plus SO4, which would be sulfur, is 32 plus oxygen is 16 times 4 because we have 4 molecules of oxygen here. So that adds up to 142 grams per mole. Right, so we have this, and we have this, and we have the total molar mass of this salt. So what we do now is the total mass, which they gave us, grams per mole, minus the salt, grams per mole as well. And then we divide that by 18 grams per mole. And that should give us how many molecules, or the number of water molecules we have in this salt. And that should come down to 10. So 10 equals X. So our final answer would be 10. Just to recap very quickly, so we had the final number, and then we had this salt's molar mass. We subtracted this, so think about it like a math equation. So we move this to the other end and becomes minus, and then that number here would be divided by the 18 grams per mole. So first of all, minus 142, and then divided, and then we have our X here remaining. Hope that made sense, and I hope that was of use. If you have any questions, let me know, but that's our moles equation, moles question for today.